Right, so graph f of x is equal to 4 to the x power, and g of x, which is equal to logarithm base 4 of x in the same rectangular coordinate system. So we can make a little table right here and start filling in some numbers. So let's say 4 to the x. So let's say we start with a 0. Okay, so that'd be 4 to the 0 equals 1. All right. Okay, so we have 0. Well, what happens if we go a little less than 0? Well, how about a negative 1? So we say 4 to the negative 1. Well, that's the same as 1 over 4. 1 over 4. Whoops, 4, not 9. Okay, so what if I go positive direction, right? So what if I say 4 to the first power? Well, that is a 4. Okay, so let's use a different color and see what this whole thing looks like. So what if I do 0 as 1, so 0, 1 would be right there. And then we say negative 1, 1 fourth, so negative 1, 1 fourth, approximately right there, maybe a little less, but approximately. And then we have 4, when x is equal to 1, this is equal to a 4. So 1 and 4 is over there. So you can kind of get a feeling. Now it's going to get infinitely close to here. I'm obviously not going to be able to draw infinitely close. But and we can actually even put in a second one here. It's going to be 16. So it's going to be, right there. It's not going to quite be a 2, but it's going to shoot up like that. Not quite straight up, but at a very slight angle that way. Okay, cool. So that's the first one, right? So let's look at a logarithm, do a dark red. So we do another xy coordinate table. And we'll plug in the same numbers, right? So we plug a 0 in. So now we have log base 4, 0. Okay. So 4 to what power is 0? 4 to the... And that doesn't work, right? 4 to no power is going to give you a 0. There's no power we can bring 4 to get a 0, right? So this is not going to work, right? That's okay, but that basically shows you that there's going to be a vertical asymptote at 0. That's where we're going to have it get infinitely close but not quite. Okay, so that wasn't a bad thing to find that out. So let's try 1. All right, so log base 4, 1. So the question is that, right? So 4 to what power is 1? Well, 4 to the 0th power. 4, or another way of writing that, 4 to the 0th power is equal to 1, right? If you rewrote it that way. So, yeah, so we're going to have a 0 here. So 1, 0, 1, 0, 1, 0. So 1 out, 0 up, 0 down. Looks like it's right there. And again, it's infinitely close to this one. We found that out where we plug in a 0 and it didn't work. It wouldn't work, right? Okay, so let's try to figure out, let's do another number. We'll do a 2. All right, so over here, so we'll say log base 4 on 2. So 4 to what power is 2? That's going to give you a weird number, not a very nice one. Let's try instead of a 2, let's try even numbers. We'll do even numbers right now. So let's say 4. Yeah, let's try 4. Oops. So 4. So 4 to what power is 4? 4 to the first power is 4. So when we plug in a 1, we get a 4. Okay, so when we plug in a 1, we get a... Or we plug in a 4, we get a 1. Okay, so 4, 1. That's my point right there, right? So we plug in a 4 over here, and it gives you a 1. So it looks like it's going to curve this way. Now, I'm not doing a very good job drawing this, but you can kind of see, if you can kind of imagine a straight line right here, you can kind of see some symmetry, right? Right along this line, right. I'm not doing a very good job drawing that line, but you get the point. It's so you can see the relation between exponents, right, and logs. You can see that they are in fact related, and we'll get more into how they're related later on.